Extraction of copper from copper pyrites. Extraction of copper from copper pyrites involves the following steps. Crushing and concentration. The ore is crushed and then concentrated by froth flotation process. What is froth flotation process? In this process, the powdered ore is mixed with water and a little pine oil, that is a foaming agent, and the whole mixture is then stirred vigorously by blowing compressed air. The oil forms the foam or froth with the air. The ore particles stick to the froth, which rises to the surface, while the rocky and earthy impurities, that is the gangue or matrix, are left in water. The froth is skimmed or collected and allowed to subside to get the concentrated ore. Roasting. The concentrated ore is heated strongly in the reverberatory furnace in excess of air. During roasting, moisture is removed. The volatile impurities are removed. Sulfur, phosphorus, arsenic, and antimony, which are present as impurity, are removed as volatile oxides. Sulfur plus oxygen gives sulfur dioxide. Phosphorus plus oxygen gives phosphorus pentoxide. Arsenic plus oxygen gives arsenic trioxide. The copper pyrite is partly converted into sulfides of copper and iron. Copper pyrite plus oxygen gives copper sulfide plus iron sulfide plus sulfur dioxide. Iron sulfide plus oxygen gives iron 2 oxide plus sulfur dioxide. Smelting. The roasted ore is mixed with powdered coke and sand and is heated in a blast furnace. It is made of steel plates lined inside with fire clay bricks. Hot air at 800 degrees Celsius is introduced from the tires near the base of the furnace. As a result, the following changes occur. Iron sulfide plus oxygen gives iron 2 oxide plus sulfur dioxide. Iron oxide plus silicon dioxide gives ferrosilicate, that is a fusible slag. Copper glance plus oxygen gives cuprite plus sulfur dioxide. Cuprite plus iron sulfide gives copper glance plus iron oxide. Iron oxide plus silicon dioxide gives ferrosilicate, that is a fusible slag. As a result of smelting, two separate molten layers are formed at the bottom of the furnace. The upper layer consists of slag and is removed as a waste, while the lower layer is called matte. It chiefly consists of cuprous sulfide and some unchanged ferrous sulfide. Bessemerization. The molten matte is transferred to a Bessemer converter as shown in the visual. The Bessemer is mounted on a horizontal axis and is fitted with small pipes called tires, through which a blast of hot air and fine sand is admitted. Any sulfur, arsenic and antimony still present escape as their respective oxides. Ferrous sulfide present in matte is oxidized to ferrous oxide, which combines with silica to form slag. Iron sulfide plus oxygen gives iron 2 oxide plus sulfur dioxide. Iron oxide plus silicon dioxide gives ferrosilicate, that is a fusible slag. Some of the cuprous sulfide undergoes oxidation to form cuprous oxide, which then reacts with more cuprous sulfide to give copper metal. The impure metal thus obtained is called blister copper and is about 98% pure. Cuprous sulfide plus oxygen gives cuprous oxide plus sulfur dioxide. Cuprous oxide plus cuprous sulfide gives copper plus sulfur dioxide. Refining. Blister copper contains about 2% of impurities and it is purified by electrolytic refining. Electrolytic refining. This method is used to get metal of high degree of purity. For electrolytic refining of copper, a block of impure copper metal acts as anode. A thin plate of pure copper metal acts as cathode. Copper sulfate solution acidified with sulfuric acid is taken as electrolyte. When electric current is passed through the electrolytic solution, pure copper gets deposited on the cathode. Impurities settle near the anode in the form of sludge called anode mud. Thank you for watching. Please subscribe this channel for more videos.